Alright everyone, good morning. This is a short update, yet another one. This time I'm looking at what they refer to as the hot end on the 3D printer. That's the part that melts the plastic filament before it's extruded onto your board. Okay. Now, you may have seen clips of it in the past when it was all assembled. I've got it all stripped now, and this is basically the component parts. I've stripped away this homemade shroud, although I've kept it as a template if I wish to use that. There is also this small fan attached to the shroud, which I can only assume was to help cool this part. I don't know the names of any of these parts, so I'll make names up as I go along. This seems to be the main part which all the other components connect to, so we'll call that the body, okay? These two wires with the orange cables attached is actually a thermistor. That's your temperature sensing device. It's held in there by two small grub screws. I think there's an M3 and an M2, both of which will not come out. So that either needs to be drilled out and then possibly retapped, or the whole body has to be redone. Not a big job, but just shite I don't know what I'll do, So in the top here, I'll call it the top. Yeah, I guess that's the top. The bottom's a lot more dirty. There's a threaded hole, and then in the front, penetrating all the way through to the back, there's a smooth hole. Again with a M2 grub screw stuck in place. That hole is for the resistor. This hole is for what I'll call the stem. That's the threaded rod part here. Okay. It is also hollow to allow PTFE Teflon tubing to pass through it. Once the PTFE Teflon tubing passes through this, it basically stops before it goes into here. But the filament will go into this part, and then this is heated via the heat in here, and melts the filament. This here is another PTFE block. It screws onto the top and allows the filament to pass through the top here. It screws onto the top of the stem. This little radiator helps to dissipate the heat which is trying to travel up the stem. You don't want to get this too hot, because then your filament will melt before it gets to the point of being extruded. Okay, so your filament is, I think, supposed to pass down through this stem, through the block, and then it's not until it hits the nozzle that it actually melts and gets extruded, I believe. Okay, so that screws on there. This screws on here. That screws into that, and then finally this screws into there. Okay, and the whole apparatus is heated using this type of resistor. Now I have no idea what form of resistor this is. It's specifically designed to generate and release heat, so that's simply well, it goes through from the other side, but it is in that hole like that. Okay, now that's quite a slack fit, so that needs to be much tighter. Now some people use different brands of compound for such purposes. Other people recommend using aluminium foil. I'll do a little bit of research on that before I determine which I'm going to use. To my mind, aluminium foil is a bit of a cowboy's approach, because there will be layers of air trapped between the layers of the foil, which is going to create a barrier to the conduction of the heat, or the heat transfer. But I've been told that that works perfectly adequately. So, but I'll do a little further research on it first. Basically, the better the heat transfer you can achieve between the resistor, this block, and your nozzle, means the quicker that your whole apparatus will heat and you can begin your print. But then you've got to be careful to try and reduce the heat transfer through the rest of the components, because you don't want your filament, or indeed the rest of your printer, overheating. Okay. Now this bit here is just simply a mounting plate, which is basically sandwiched between these parts. This hole here allowing the stem to pass through that and into your block. And then these slots, I believe, were for mounting to the bottom of the carriage. And whoever had this extruded before me had introduced two sort of extenders. I don't know what you'd call them. They're like little wee hex nuts, but quite long, between here and the top of the carriage, basically penetrating through the little shroud that they had made up. Now, as I've removed the shroud, I could, I guess, just bolt that directly onto the bottom of the carriage. But at this point in time, I'm concerned about overheating, because it will be a lot closer to the carriage now than it was in the past. Right, sorry about that, I just had to reach down and pick these parts up. So that's it, folks. I need to outstanding issues at the moment is that I need female connectors, 4mm red. I still need to determine a way to connect these wires. I'll need to get a thermal compound. I was thinking of just using the thermal compound that I have here. This is ceramic 2 trilinear ceramic thermal compound by Arctic Silver. This is basically used for the fitting of heat sinks to computer central processing units, or CPUs. So I think that will probably suffice. One of the issues I do have is that this small nozzle is completely blocked, so I've got to try and recover that. It's a 0.5mm nozzle. I don't know if you can see that on it there. There is the number 5 stamped into it. So I've been told that equates to a 0.5mm nozzle diameter. So that's 10 minutes now, folks, so I'll leave it at that. I'm going to try the compression out on this video now. And until next time, hope you've enjoyed this short video, and catch you again soon. Bye for now.